Module 1 Matrices. Question 1. Calculate the matrix expression shown. For this, we are going to start with the elements in row 1, column 1, that is 2 plus 2 plus 4 minus 8, and then elements in row 1, column 2, 6 plus 6 plus 12 minus 24. We continue with the elements in row 2, column 1, 4 plus 4 plus 8 minus 16, and finally the elements in row 2, column 2, 1 plus 1 plus 2 minus 2. And this gives us the matrix 0, 0, 0, 2. So the answer we are after is option E. Question 2. Consider the following four matrices. How many of these matrices are diagonal matrices? In a diagonal matrix, all the elements on the leading diagonal are non-zero. There are three matrices that satisfy this condition. All the other elements are zeros. There is only one matrix that satisfies this condition, so the answer we are after is option B. Question 3. The matrix equation shown has a unique solution for x and y. Which one of the following matrix equations has the same unique solution for x and y? Let's write the equations from the matrix equation. That is 4x plus 2y equals 15 and 2x minus 4y equals 4. Now let's write the equations for the matrix equation in part A. That is 2y minus 4x equals 15 and 4y plus 2x equals 4. We can cross out this option since these two equations are totally different from the ones given. We do the same for part B, and that is 2y minus 4x equals 4 and 4y plus 2x equals 15. So we can cross out this option as well. In option C, 2y plus 4x equals negative 4 and negative 4y plus 2x equals negative 15. We can cross out this option also. In part D, 4x plus 2y equals 15. This is identical with the first equation in the matrix equation given. And then we have 8x minus 16y equals 16. We can divide this equation by 4 and we end up with 2x minus 4y equals 4. So this is the second equation in the matrix equation given. These are the equations that are going to have the same unique solution. Now let's check option E as well. Negative 4x plus 2y equals 15 and 2x plus 4y equals 4. So we can cross out this option too. So the answer we are after is option D. Question 4. Matrix M1 is the 5 by 1 column matrix shown. A second 5 by 1 column matrix M2 contains the same elements as M1, but the elements are ordered with the largest value at the top and the smallest value at the bottom. 25, 15, 12, 9, and 3. Matrix M2 equals P times M1, where P is a permutation matrix. The question is asking to determine matrix P. Let's start with number 25, which moves from row 3 in matrix M1 to row 1 in matrix M2, which means that we need a 1 in row 3, column 1. Number 15 moves from row 4 in matrix M1 to row 2 in matrix M2. Therefore, we need a 1 in row 4, column 2. Number 12 moves from row 1 in matrix M1 to row 3 in matrix M2. Therefore, we need a 1 in row 1, column 3. Number 9 moves from row 5 in matrix M1 to row 4 in matrix M2. Therefore, we need a 1 in row 5, column 4. And 3 moves from row 2 in matrix M1 to row 5 in matrix M2. Therefore, we need a 1 in row 2, column 5. So the answer we are after is option B. Question 5. A factory employs the same number of workers each day. The workers are allocated to work in either the green building or the white building. The workers may be allocated to work in a different building from day to day, as shown in the transition matrix below. The green building must have 36 workers each day. Each day, the number of workers in the white building will be, to calculate this, 0.52 of the workers in the green building from today stay in the green building the next day, and 0.24 of the workers in the white building today move to the green building the next day. So we have 36 times 0.52 plus W times 0.24 equals 36. If we solve this equation, W equals 72. So the answer we are after is option C. Question 6. 4 families visit an amusement park. At this amusement park, there are 3 rides: a roller coaster, a Ferris wheel, and go-karts. Each ride has a different ticket price for adults and for children. The number of tickets that each family pays for is shown in Table 1 below. The data in Table 1 can be converted into a 4x6 matrix V. The ticket price per ride is shown in Table 2 below. The data in Table 2 can be converted into a matrix W, where W equals the matrix shown, where RA is the ticket price for one adult to ride a roller coaster, and RC is the ticket price for one child to ride the roller coaster. The matrix product V times W produces a new matrix L. The question is asking to determine what the elements in matrix L show. When we multiply V and W, we multiply the first row in V by the first column in W, and that gives us the total cost for the adult tickets for all the rides for family 1. Then when we multiply the elements in row 1 in matrix V by the elements of column 2 in matrix W, that gives us the total cost for child tickets for all the rides for family 1. When we multiply the elements of row 2 in matrix V by the elements in column 1 of matrix W, that gives us the total cost for the adult tickets for all the rides for family 2. And we continue like this, and we can say that the elements in matrix L show the total cost of all adult tickets and all child tickets for each family. Question 7. Each day, all employees of a large company will work at one of the 4 locations, L1, L2, L3, or L4. The table below shows the number of employees at each location every Monday. The transition diagram below shows the change in the number of employees at each location from day to day. The question is asking which one of the following statements is true. First, we are going to calculate the number of employees on Tuesday. Let's convert the transition diagram into a transition matrix. We multiply the transition matrix by the matrix showing all the employees at the 4 locations. So on Tuesday, we have 45 employees at location 1, 35 employees at location 2, 185 employees at location 3, and none at location 4. For this reason, we can cross out options A and B. Now we multiply the transition matrix squared by the number of employees at the 4 locations on Monday, and we obtain the number of employees at all the locations on Wednesday. We can cross out option C, and the answer is going to be option D. On Wednesday, there will be no employees at locations L2 and L4 only. We can also calculate the number of employees at the 4 locations on Thursday, and we can cross out option E as well. Question 8. 4 teams, J, K, L, and M, compete in a tournament. Each team plays one game against every other team. In each game, there is a winner and a loser. To decide the winner of the tournament, the sum of the one-step dominance matrix D and the two-step dominance matrix D squared for this tournament is determined. This sum, D plus D squared, is shown below. The 2 in the second row shows that the total number of one-step and two-step dominances that Team K has over Team M is 2. In the first 2 games, Team J defeated Team K and Team L defeated Team M. Which one of the following is the correct one-step dominance for this tournament? The fastest and easiest way to do this question is to put each matrix in the calculator and check for the correct option. However, this is the way to solve this question. We let D equals this matrix. We have a 1 in row 1, column 2, because Team J defeated Team K, which means that there is a 0 in row 2, column 1. Also, Team L defeated Team M, which means that there is a 1 in row 3, column 4, and a 0 in row 4, column 3. So this matrix, which is D, plus this matrix, which is D squared, must be equal to the sum matrix already given to us. Note the thing that there is a 0 in row 1, column 2 in the matrix D squared, and this is because if we add up those 2 elements in row 1 and column 2 in the 2 matrices, 1 plus 0 must be equal to 1. Similarly, in matrix D squared, we have a 1 in row 2, column 1, because 0 plus 1 must be 1. Similarly, in row 3, column 4, 1 plus 0 equals 1. And in row 4, column 3, 0 plus 1 equals 1. In the next step, label the 4 elements in the top right corner with A, B, C, and D. Let's multiply row 2 by column 3 in matrix D. This is going to give us the element in row 2, column 3 in the matrix D squared. So we have 0 times A plus 0 times C plus C times 0 plus D times 0 equals 0. C plus 0 must be equal to 1. Therefore, C equals 1. We are now going to multiply row 2 by column 4. So 0 times B plus 0 times D plus 1 times 1 plus D times 0 equals 1. D plus 1 equals 2. Therefore, D must be equal to 1. We are now going to multiply row 1 by column 3. And that is 0 times A plus 1 times 1 plus A times 0 plus B times 0, and that equals 1. So the element in row 1, column 3 in matrix D squared is 1. A plus 1 equals 2. Therefore, A must be equal to 1. Now let's multiply the elements in row 1, column 4, and that gives us 0 times B plus 1 times 1 plus 1 times 1 plus B times 0 equals 2. B plus 2 must be equal to 2. Therefore, B must be equal to 0. We can continue in this way to determine the other 4 elements. However, if we look at the 5 matrices, we can see that we already have the answer, and that is option A.